What if I told you that diseases such as diabetes, depression, and obesity could be linked to something hidden in your intestines? That's right, it is your very own gut microbiome. Today, I want to explore the significance of the paradigm shift that bacteria are not always bad for you and can provide better treatment options to combat obesity, diabetes, and a plethora of non communicable diseases. This will revolutionize how we think and treat certain diseases without the use of conventional drug therapy like antibiotics. In order to get a good grasp on the significant impact that the microbiome has on science and medicine, we must venture into history of the microbiome's significance, how it changed the way we used to think, and the future implication of this discovery. What is the microbiome, you might ask? The definition of this term can be referred to many different components, but it is still being debated on how to best encapsulate the full meaning of this word. For this video, we will be referring the microbiome as, quote, ecological community of commensal, symbiotic, and pathogenic microorganisms within a body space or other environment, end quote. This definition is linked to Joshua Lederberg on his interpretation, a definition used by many recent papers. Until the invention of the microscope, where the father of microbiology, Antoine van Leeuwenhoek, peered into the world of microorganisms, we had many theories as to the origins of diseases. The idea that microorganisms are the cause of diseases began to catch on due to the works of Leeuwenhoek and Robert Koch, causing a massive paradigm to shift the causal agent of disease from bad air and spontaneous generations to microorganisms. From a clinical side, Theodore Estridge was a pediatrician who was given credit for providing the clearest evidence of the role of the gut microbiome in a healthy subject. His study was famous for his role in discovering the existence of E. coli, the genus named after his last name, Estridge. By studying healthy and sick infants, he was able to collect samples and made a detailed report on the importance of the bacteria in the gut, a huge step for clinical research. This discovery influenced our perception on the microorganisms as a threat that must be eliminated. This sentiment is shown in how we conduct research, apply medical care, and cultural practices such as using hand sanitizers and antibacterial soap. Yet science was experiencing another paradigm shift that further complicates the concept that microorganisms are all bad, with the rise of Sergei Winogradsky's research on microbial ecology in the environment. Through Winogradsky's research on the complex interconnectivity of bacteria in the soil that gave rise to our current understanding of the nitrogen cycle, and so much more, the implication was clear. Microorganisms live everywhere in the environment that provides a complex relationship balance with all living creatures, good or bad. Yet it was only within the beginning of the 21st century that research on the microbiome began to establish connections to the health of animals, plants, and most notably humans. What was going on before this connection was established? The paradigm had to change. What is this paradigm change? Dr. Gabrielle Berg and her whole team said it best. There has been a fundamental paradigm shift in our understanding of the microorganisms, and it is now accepted that all eukaryotes are meta-organisms and must be considered together with their microbiota as an inseparable, functional unit. We can examine this more closely with one study conducted by Dr. Els van Nood and her team to see if conventional treatments, like an antibiotic, is comparable to the infusion of donor feces in combat against recurrent C. difficile infection. When examining the study, we can see in Figure 2 that the benefit of the infusion outweigh any antibiotic options, especially with a significant decrease in the number of relapses. This is significant because this shows how antibiotics may not be the magic bullet, and that the microbiome infusion could be the key to solving gastrointestinal diseases. The study later follows up with each patient to see if there's any relapse of disease or continuous adverse symptoms. In Table 2, we see that there are many adverse events during the initial infusion, but that seems to be expected since any introduction of foreign body and bacteria will lead to the body defending itself and having some reaction to it. Most symptoms were gone within 3 hours though. Interestingly, the follow-up shows very little adverse effect with a small group of people having constipation. However, the results for the vancomycin groups had many relapses and adverse events during their follow-ups. When 18 of the antibiotic treatment relapsed, they were given infusion treatment, and surprisingly, 15 of them were cured. These results are not shown on the graph. What does this mean for the future? It means we can see a rise in new therapy in medicine that can tackle diseases such as obesity and even depression. We can even see it in new ways of handling agriculture as an alternative to antibiotics, having greater understanding of coevolution, and tackling nutritional science in a new way. However, we must proceed with caution since we have yet to fully understand the microbiome. There is even a concern on addressing many ethical questions that will arise, including the validity of manipulating our own microbiome, while possibly indirectly manipulating other people's microbiome without their consent. Our greatest public health challenge is to break the paradigm that microorganisms are all bad that continues to persist in our research, medicine, and society. Once we break hold of this paradigm, we will enter a new era of medicine and nutritional science through new public health policies and programs using the microbiome. With that, thank you for joining me on this journey.